Hello, everyone. So let's share my screen. And today we're going to talk about PDF structures, the different shapes of PDF files. And why isn't it showing? If you check previous streams, I mean, if you know my sorry for that. So basically, I was checking. This is one of my file exploration live streams, and I did a couple of them right now. This is number 23rd, and this is kind of a follow up of the very first on PDF Basics. So basically, in PDF Basics, we explored how to make Hello World PDF from scratch. And now we're just going to extend that so that you can know how to handle more or less all kinds of PDF out there. With so basically, because in this stream we explored PDFs that were only in a very specific shape, and the most basic one to edit and create. But there are actually a few different ones that is worth knowing. So in our classic PDF, it looked like this. There is a signature, then there is a sequence. There is a sequence of objects that refer to each other. They start all with this object structure and this object keyword with a object number, a generation number that is 99% of the time 0, and an object. And then at the end of the object there is a end object. The references are with a number, a generation, and uppercase R. Names are these things starting with slash. So specific names, not immediate strings. These syntax here are the dictionaries, which define, for example, a key is set to a specific value, and this key here, pages, is set to this value. So basically, that's dictionary structure. Then there is also, for example, in this object number 2, there is a definition of this kids value key that is set to an array, and the array contains only one element that is a reference to object 30 and object 30 and so on. And very importantly, at the end, after all the sequences of objects, there is this XRef table with the XRef keyword, cross-reference table, keyword, yes, where the current list of references will start. So it starts at offset 0 and it ends at offset 6. Offset 0 is always taken. This means this is free slot, and this is in use. And then there is a 10 digit in decimal number, which is the offset in decimal to each of the objects. And then there is maybe that's a generation, but again, this is mostly 0 as far as I remember. So for example, this means that object 1 is at offset 11. And indeed, with the hex editor, I select what's before 1, and I can see that it's object 11, offset 11. Okay, no question so far. So and at the end, after the XRef, there is a start XRef keyword with a pointer in decimal to, which is actually the offset of the XRef table, and end of file marker, and in between there is a trailer special object, which is a dictionary, and it sets, among other things, very importantly, the root object. So it gives the PDF reader the reference to the very first object of the document. And in this case, it's object 1. Okay. And we, as mentioned in stream number 2, if you're curious, where is stream number 2? PDF leaks and parasites, maybe parasites more or less. You can manipulate PDF structure in various ways. You can even entirely rename remove the XRef table, it will be restored. The length parameters will be most likely restored. Only in extreme case they are required. So basically, this is the PDF structure that we explored during the first stream, that we created during the first stream. And this is the most easy to understand and the easiest to hack, to create from scratch. Because again, as you can see, this is pure text. This is totally not optimized. This is never compressed. It's like a big waste of time. There are objects. It's easy to create a PDF that would have a huge cross-reference table and therefore a huge waste of time. Okay, so a tiny update, and it's actually an incremental update to this structure is indeed incremental updates of PDF. Because I forgot to mention, but in the previous stream I didn't mention some elements that are typical. For example, MediaBox is giving you the dimension, the basic dimension of the page. Of course, if you're into printing, you will know that there is a crop box, there can be the bleed, there can be all kinds of dimensions, but MediaBox is the basic one. And these are the basic dimension. Because basically the PDF will work if you remove the MediaBox parameter, but it's just something I didn't cover in the first stream that is just making it a bit more standard. Another thing is very common too, is that in the trailer you have an ID sometimes that is a pair of two numbers. They are usually much bigger than this. They are just random numbers usually to differentiate documents. And also info in the trailer dictionary, which reference to things like the title of the document, the keywords, and so on, the author, the creation date, the modification date. Also, this is the first example that we didn't cover before of a string that is not in a stream. So it's a string, but it's not in a stream, and it will have some minor impact on encryption later in this stream tonight. So incremental updates is just exactly the same thing, except that, so here imagine you have a document that's a normal PDF, right? And you have a top secret message and you have an XRef, and I will scroll very slowly, and then you have the XRef, the pointer, and so on. Okay, but PDFs were created at a time where access to floppies and so on was extremely slow. So even hard disks were slow back then. So basically, you wanted to. It was very common to be able to update the document, but not rewrite the document entirely, but just an incremental update, just a tiny update of what you wanted to modify. And this is exactly the mechanism. And now I'm scrolling further, and suddenly you have new objects, and I'm redeclaring object 4, and it's not top secret here, but it's just different. It's just entirely different. It doesn't matter. And there is another XRef, and here it shows you the XRef that is used for that with this weird numbering. So here I have to declare there is object 0. I mean, that this item starts at index 0 and there is one item. And then let's jump instead to just object 4, and there's just one item. So basically, this XRef updates the previous XRef just for object 4 and gives the new offset of object 4. So this is correct, 4549. And even though there was a object, there was how do you say? There was an object already at a different offset referenced by the previous XRef table. And now let's scroll down to the page, and this tells you why PDFs are parsed bottom up. Sorry, because now there is a new static XRef pointer which points to the new XRef, and then there is a tiny XRef that just only updates one object index offset. There is a trailer, and the trailer has a special element which is previous, which is the pointer to the previous XRef table. So the chain of trailers then it will go back to the next trailer. So as you see that it passed bottom up, but following a chain of incremental updates. So to detect an incremental update, it's now extremely uncommon as far as I could tell, like very, very few. And the only examples I found in the wild were just minor typos at the bottom of a document. Like I haven't found anything super incredible, but there could be some hidden data behind an incremental update. And to just remove the incremental update to get the original document, well, just delete everything that was after the successive end of file markers. Okay, so this file works as you would guess. Nothing special here. And now what else? So this is for incremental updates, which is the last special case of this weird XRef table. Now, before we move on to different, I forgot to mention, it's also very handy if you want to extend a PDF with something, like, for example, and you want this payload, this extension to be at the end of a PDF. And this is exactly why I created this article on PagedOut. How can I say? In the first issue of PagedOut, the magazine. So that's PagedOut, if you're not familiar with it. And page 16 is my article. If you're not familiar with PagedOut, all articles in PagedOut are just a single page. And the address is pageout.institute. And basically, my article was adding an external data to any PDF. And you can do that with several tools. And for example, a very elegant way to do so, even from any PDF, is just to add a new stream object with an incremental update. The new object will be stored after the end of the file. It's very easy to revert. And you can automate that. And basically, that can apply to any PDF. So to turn easily and elegantly a given PDF into a PDF zip polyglot, you can do that, for example, with just a single script. So PyMu PDF with just a single few lines of PyMu PDF to embed the zip in a stream object, and to have all this appended to the end of the file, which will guarantee that the original file will stay the same, and the zip will be at the end of the file, because again, it's at the bottom of the file. So the zip will be parsed correctly. Okay, so filters. So far, we always manipulated pure data. But of course, standard PDFs, if we look, for example, at PagedOut, this is PagedOut, and we will see very quickly that it has binary data. And so, for example, here we see that it's an image, color space, blah, 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 blah. And there is a stream. And here, there is the thing that is called filter DCT decode. And DCT decode is the filter of JPEG. So basically, we can see that indeed the data start with FFD8, FFFE, which is a JPEG image. So basically, raw data would be stored without a filter, and filter is just saying what compression or decompression algorithm to apply to the data that is in the stream. So, for example, we can take this stream, this pure raw stream, and with just a very tiny script in Python, for example, we just apply compress, and we will get it as pure compressed binary. But then we can even display it as hexadecimal. And so the standard compression algorithm are flate decode, which means it's been compressed with deflates, which is kind of the compression of zlib and the standard zip compression. Let's put it that way. It's not exact, but the usual one, the easy one, this one, the zlib compressed one. And for example, JPEG images have this very specific DCT decode compression. These are the two most used. But on the other hand, you can do the opposite, and you can turn any binary to something like pure hexadecimal in ASCII, so ASCII hex, or ASCII 85. If you're familiar with this kind of specific, it's not base 64, it's not on 64 characters, it's on 85 bytes, and it's a bit specific to Adobe, not so much used. But anyway, ASCII hex decode makes it that any data could be compressed, but still pure ASCII, because you will see it as hex. And basically, you can just run that with a standard, how can you say? So basic, I didn't write it down. So with, for example, the tool mu tool, with the tool mu tool from new PDF, and you will do a clean and then Z to recompress, but apply ASCII hex decode to a file. It will turn any file into hex, into how do you say, pure ASCII. So basically, here is again our PagedOut with some binary and so on. And here I just use mu tool to decompress. So you see that the file is now much bigger, but now everything is decompressed. So every text is in clear, let's put it that way. But on top of that, all the streams are decompressed. And if there is a pure binary stream, so the page content are in clear because they are already text and they were just compressed. November. No, you see, for example, you see now the text of the page is purely, it's completely in clear. So let's see if we open it. I decompress it. This is now a much bigger file. I hope my machine will. Okay, why is it so slow? Is the file is so big? Ha ha ha. Why is it? What is it? 800 megabytes. Okay, that's probably a crazy file to edit. Anyway, so basically you see that all the text is in clear, and now even the how can I say, all the objects, the stream will be in ASCII converted. If they were pure binary, now they are converted in ASCII. So that makes the whole file, any PDF file, can be turned in pure text via just this argument, via just using the filter ASCII hex decode on the streams. And most tools like QPDF and new tool have an option to use ASCII hex decode to turn. So basically, you can turn any PDF into something editable in a text editor, even production ready PDF, even PDFs in the wild. So much easier for people to manipulate PDFs and to view the content. So now, if you look at any content, let's take the original file. So that was indeed November, but you saw that the text is not purely in clear. I mean, it is in clear, but you can see, where was it again? That meet the balloon key derivation. Oh yeah, that's the title. You can see that sometimes there is kerning information between the text. Okay, so that's a minor problem, but at least you can see that all the text is readable, and this was again done on an actual PDF that you can see in the wild, that you can get in the wild. So that's it for filters. You can chain filters. Where is it? Filters, exactly. So let's take again our PDF, and that's the same PDF as before. Catalog, pages, and so on, the same objects, but now the page content is turned into, so it's been compressed, but then there is another filter that was added on top of it to turn the compressed data into ASCII display. I mean ASCII, so I don't have to show, you can clearly read the binary if you want. And indeed, you have 78.9c, which is very typical of a deflate stream. So this is the page content that were compressed, but now they're expanded because ASCII hex decode was used on top of it, which makes it editable in a text editor. And this marker at the end is just to say a very unusual way, I mean, a very Adobe way to mark the end of a hex stream, but it's not strictly required. So as you can see now, this is again my PDF, my classic PDF, but now we applied filters, and in this case applied filter to apply compression, but also expansion to ASCII, which would turn again any PDF into editable, text editable content. So of course you could remove the ASCII hex decode, the flayed decode, so that you have the pure hex version of the page content, but I'm not sure there's a point because it's text after all. Okay, so now among the different kinds of PDF documents that you can see in the wild, there is the linearized PDF, which is something that is called web optimized, because if you realize, you need to download the whole PDF to be able to render anything. You need to go to the end of the document to be able to display even the first page, which is maybe not optimal for a slow bandwidth or huge documents, when you want to see some pieces of the content um, before how can I say, well, maybe it's not the file that you want, or you could cancel the download at this point. So a linearized PDF, let's get one, is made of two sections, or let's use another viewer. So basically it's a PDF that has a bit of the document at the beginning of the document, and then the rest. So basically the idea is that there should be enough stuff at the beginning of the document to render the first page, meaning the first page, and then the document resume with the rest of the file. And basically it's very easy to notice, because you will have this linearized keyword in the very first object, and then some parameters specific to the linearization. So very something extremely unusual and very easy to distinguish. And then a small XRef with a first trailer, and then the rest of the file goes on. And then at the end there is another XRef and another trailer, which means basically, when you see a linearized file, I would suggest that you convert it to something else. So now this is my linearized files. If I do mutool clean on it, linearized, and now what's the file I get is back to a normal structure. It has kept the linearized object because it maybe didn't understand it's a linear object, but now the same file is back to a normal structure. So and again, this is a classic editable, hackable XRef structure, which is again what you might want to do. You can still do if you want to modify or learn from the PDF. Okay, so that's it for linearized. Not much to say, except that if you see these files, then at least know that if there is an incremental, as you saw in the case of linearized file, there will be the Prev marker, but there will be also the linearized keyword, which is extremely very important to notice. So basically, when you download any PDF and you want to edit it, just know what you how can I say, just know what to expect. Now, as you saw, that PDF XRef is totally unoptimized, and there is a lot of loss of data and dodge, of spacing, and the XRef could be compressed and so on, which is exactly what Adobe came with. And typically, when you would create a modern PDF version 1.5 and further, they may not have this old school, this classic XRef style. and this is called stream object and object stream. Maybe I'm wrong. No, it's a stream object and object XRef. Sorry for that. I forgot the exact wording. So basically, where is it? Where is it? Object streams. So this is a PDF with an object stream and also an XRef that has a very different shape. So um, object stream means that we can have a stream object that contains other objects. So how does it work? There is an object that has a type object stream, the length of the stream, as usual, the classic length of the stream, 262, yeah, that works, and meaning the amount of object that are stored in the stream. So here we have 1, 2, 3, and 4. And then there is, before these 4 objects in the stream, there is an index of all the objects. And this first 20 means how long is this index in the stream. So basically how it works is, this is a type object stream. There is the whole length of the stream. There are 4 objects in it, and all the objects are stored after the first 20 bytes. So after the first 20 bytes of the stream, the objects are stored. And then the index says object number 2 is at offset 0 after the start. Object number 3, we'll see, is at offset 34 after the object start, and so on. So basically this means object 2 is at the very beginning, object 3 is 35 bytes further, object 4 not further in absolute, right? Absolute, I mean relative to the start of the object. And so basically object 5 is here indeed 169. Object 5 is at the beginning, I mean is 169 from the beginning of the objects, which is itself 20 bytes further than the beginning of the stream. Now this indeed enable PDFs to have no how can I say, no object and end object markers and no new lines and so on. But remember that all these could actually, in the wild, in practice, it will be compressed. So you can apply a filter of a deflate, decode deflate. What is it? Deflate decode, flate decode. Sorry, not deflate. It's not inflate. It's not deflate. It's flate. Okay, whatever. So basically, all these would be compressed. Now you can see that, and indeed, in the wild, do I have an object that is? Do I have a PDF that is? Okay, I have a PDF here, and it's so now you see that this PDF that I got from wherever is linearized and also has object stream, and the stream is compressed. That's the length of the stream. This object stream contains 92 different objects, and then the header, the size of the header of the index will be 945 bytes. So that's an object stream. So which is why in this kind of PDF you will not see the things in normal. But now there is another thing. Okay, there's a weird that there's a lot of data. You don't see in XRef either, because it wouldn't make sense to optimize the stream objects and not optimize the stream storage, and but not optimize the way the XRef is stored. And let's look at the XRef. And the XRef, so start XRef pointer is as usual. Then there is, it points to an object 464. Oh, that's 44. Why is it didn't work? This is not, this is offset 464 and here are 441. I'm not sure why this is incorrect, or maybe it starts here. Okay, I don't remember. Okay, that's weird. Anyway, So these are my comments, right? This is not relative. So basically, this is an object that has a type of XRef, and that's the length of um, the stream, because now the XRef is in the stream of an object. And what is very, very important, I mean, what is important, index, I'm not sure what it is about. And the w are the width of each element in the stream. And basically it means 1 byte. Here it means 1 byte, 2 byte, 1 byte, 1 byte, 2 byte, 1 byte. And this can be increased if the file is bigger. So you can even set this, like if you had a bigger file and you need more bytes to store the offset, for example, then you could make. But basically they wanted to get rid of this superfluous 10 bytes that you very rarely use. Okay. And now how it works is that object 0 is not in use. And so it starts with 0 and the rest should be 0. Object 1 is not compressed, so it means it exists as itself, and the offset of the object is the offset of the object in the file is that object is offset 10. So basically, indeed, it's offset 10. Okay, I got something wrong, but maybe it's because of those bytes. Now, and the last version, the last possibility of this XRef object storage is here. The first byte, the first value, it should be, again, this size here depends on this parameter here, 1 to 1 for 1 byte, 2 bytes, and 1 byte. But as far as I know, since this can only go to 2 maximum, this should be always only 1 byte, right? And now, if this first value here means is 2, then it means that this object, so we were object 0, 1, 2, object 2 is compressed. It doesn't exist in clear in the file. It's in a stream object, and this is the object where this is the object that is storing this object. So as we saw earlier, object 2 is indeed compressed. Object 2, which is referenced here, that's object 2, and object 2 is stored in object 1. So this is what it means. And then we see that the index within the stream, indeed, object 2 is the first, is the nullth, so the first object in this object stream. And object 3 is also compressed in object 1, and this is the next object, and so on. And then object 1, 2, 3, 4, 5, 6, object 6 is present in the file. It's a 1 and not a 2. Object 6 is present in the file at offset 14C. And you see that now offsets, oh yeah, that's why I was wrong earlier. The great thing here is that the offsets are in hexadecimal. So object 6 is at offset 14C. So now you see the logic, how objects can be in PDF 1.5, objects can be not visible in clear in the file. Let's see again. So here you have the XRef object 131, and you have the parameters of the offsets of the XRef. This is an XRef, and indeed, and this is an object that is storing a lot of 945 objects itself. So now if we actually compress this file, well, I mean, if we just run mutool clean on this file, maybe, let's see, it converted this file back to a classic shape. So just with mutool clean, for example, now I'm back to an original shape where I can more easily understand the structure of the document. There is no more objects stored in another object, and there is no, the XRef is in clear. So much easier to edit. So now you can see that this PDF here that I looked at is very, how can I say, it's linearized, has XRef objects, has stream objects. So definitely not the kind that you can modify easily. But on the other hand, with just running mutool clean, you will get a PDF that is much easier to run. And now if you do again, if you do this, but instead you do decompress A, that will decompress, and that will also dash D dash A, that will decompress the stream. But on top of that, that will turn everything into ASCII hex code. So this is the same PDF again. And now you see that all the text is completely in clear because I asked it to decompress all the streams. And even better, even the PDF, even the all objects of this document will be stored in pure ASCII. So you see that now with, for example, just a single command like mutool clean -dig -a, you will take a web optimized with compressed objects with nothing in clear PDF into exactly the same document, but now you can very easily edit it and hopefully drop it in a text editor, and this is your file. So now you can edit very easily, combining these efforts. We achieve high. I'm not sure what this document is. I hope it's not too confidential. DeepSeek technical report. Okay, and so now we can do exactly what we did in the original in the first stream. I can run Sumatra. Okay, whatever that is. Yeah, this is stuff from the past. And I run it. This is the exact document from earlier, but now DeepSeek technical record. Do I have it? Where is it? Introduction, contents, architecture. Okay, so here we can see the tabs that we saw earlier. We can see the bookmarks that we saw earlier, and now we can probably DeepSeek v3 as generative model. We present a strong. You can see exactly the text, right? And now we can modify it straight away. So, and initially, once again, this document was totally in unmodifiable form. So just a standard tool like mutool will just transform this PDF into something you can edit directly. I still want to look where I can hack some text just to show you. The content introduction, blah, blah, blah. Discussion, batch. So again, you see that the text is not, you can see that this standard, because these are kerning operations to modify the spacing between each character. So basically, it's not entirely, not all the words will be, they might be complete evaluation, or they might be cut because the software decided to change the kerning between these two characters to make them slightly closer, for example. But experts, a strong mixture of experts. So experts. Here we see a strong mixture of experts, and we see that if I modify it, did it work? No, it didn't work. It's not the same file. Okay, did I fail something? Okay, maybe there's another one. I wanted to show something that is editable, but maybe it didn't work. Or maybe I screwed up. This is not the same file. File out. This is the same file. So expert. Do I have experts? Oh, mixture of experts. See, now I modified that part. So maybe the part that is before. So if it's confusing where you should modify the file, another thing I recommend is using QPDF, because QPDF has a -QDF mode, which is pretty nice. Let's see now, QPDF -QDF and test QDF, because it will annotate. There we go, single command line, and it will annotate the original objects and also the page content for the what was on which page. So we say, if we say page one original object, and now it's telling us the content for object one. So QPDF mode, the QDF mode is nice to even add you some extra information to be able to understand the original structure of the PDF. So Mutool, Clean, or QDF, or probably many other tools enable you, make it possible so that to immediately convert to something very nice to edit. And yeah, so strong. Why can't I get the? I wanted to modify some word live, but maybe there is kerning at the wrong place. Okay. Okay. I cannot get proper modification of the file. I mean, you get the idea, but that's the thing, right? If the text is not properly, if the text is not, is always cut precision, it's difficult to do search. You need most likely to do a regex of some kind. Okay, you get the idea. So basically, initially the file was very impossible to modify by hand. Just running something like QPDF-QDF or Mutool Clean with ASCII hex mode, then will give you something very easy to edit, and that is still rendering exactly as before. So a good start to but it's also very important that you are able to identify that the file is linearized, that there is an XRef object, and so on. Because the original PDF we saw in the first stream were very naively simple. Now, another very important thing in PDFs is encryption, and often misunderstood. So in a PDF, in an encryption PDF, this is just my classic PDF, and then this is an encrypted PDF. And what has changed? The title, if you recall, the title was something like in hello or something. Now it's in hex, and it looks weird. Then the stream the streams will be encrypted, and in the root, in the trailer, you will have this encrypt object. In the root, you will have this encrypt name pointing to an encryption object, a dictionary. And the encryption is telling you a few things. Important thing, the length is the length of the key. When it's 40, it's very weak. V is the number of the version, so V1 is actually very weak. And to use that in QPDF, for example, you need to set up the QPDF. You need to add a parameter so that it accepts to allow weak crypto. And there are two passwords for a PDF. There is a user password to be able to open the file, and there is the owner password to be able to modify the file. Then with encryption comes restrictions. So if I open this file, it will work, but I will not have the copy nor the print. I cannot print. The print is disabled. And the only thing that makes it disabled is that in the encrypted PDF, the parameter P is actually some kind of bit field, and this is the thing setting the writes. The P value is actually used for the decryption, so you cannot change it entirely. But the thing is, how can I use open the PDF without any interaction? It's encrypted, and this P is set. It's because the default user password is empty. So basically, with the user password, the being empty, which is what I set, the the PDF will auto open, will have enough stuff to render, but still, because the content is still encrypted, the access rights need to be exactly preserved as is. So you cannot easily access, but of course you can just run decrypt and mutual decrypt encrypted. Oh, it doesn't have this, or QPDF decrypt. I don't remember. QPDF dash dash decrypt decrypted. And now I got my file, and yeah, encryption is gone. And with encryption being gone, the restrictions of printing and so on are gone. So now I can print, I can copy. So this is really a bit confusing, because what does access rights have to do with encryption? Well, it's because the field to define these access rights is used in the decryption. But if you remove the encryption entirely with just a single QPDF decrypt parameter, and many other tools actually implement that, then you remove these restrictions right altogether. Although it's not because there is no interaction that the file is not encrypted. So basically, it's a common trick for malware with weak parsers, so that you see that the streams are encrypted. So here you see the stream being completely encrypted. Where was it? Right, nothing to do. There is encryption. Encryption is applied to decrypt all these strings, and basically, even though the file will open and potentially exploit people. So encryption is a very annoying thing. And actually, I remember one of my first interaction with PDF was in 2008 or something, to implement decryption for PDFs at Symantec. So very decryption has to be implemented, because it's not because there is no prompt that there is no encryption. And also it shows you that the access rights are just an information. Some tools might just ignore it entirely. I think Google Drive was ignoring it. Maybe Sumatra actually. Some versions of Sumatra didn't care. Um, let's open the file, encrypted file. Please wait, rendering. Can I copy that? Oh, copying text was denied. You see, it's very weird that it's telling you it's denied. It is technically possible, and it's just an information. And I think earlier version of Sumatra didn't care, and were just enabling you to copy paste. And again, Google Drive or other software. I mean, I'm not sure Google Drive, but what you can do sometimes is just, oh, you cannot copy paste. You can print it as a PDF. It will be created as a new PDF, which is basically what you're doing. Of course, it will not guess the password, so it's just recreating a new PDF from the file. So basically, decrypting gets rid of all the, obviously, encryption, all these problems with passwords. You need owner password if it's set. But if it's set, on the other hand, if you don't have the password, you cannot open the file. Sorry for that. And just access right, that will remove access right at the same time. So just to summarize, whenever you look at a file that has something like linearized, incremental update is very unlikely, but ObjStm, XRef stream, then convert this file to something that you can manipulate easily. If there is encryption, which is something that you can see via the encrypt parameter in the encrypt key in the trailer dictionary, then you can very easily, you can tell that it's encrypted, and you just run decrypt, one of the tools like QPDF, to decrypt the file. And then you fall back on a very standard PDF that you can manipulate very easily, that you can recreate, and so on. And then you can modify, merge stuff, and so on very easily. in recent years, beyond closed source models, Mistral, DeepSeek, and so on, you see this, all the text is in clear. And this is something that you can easily do with 2 calls if the file is encrypted, to get the original content of the PDF ready to modify. And again, you can very easily modify this. As usual, remove the XRef table entirely, and then you do your manipulations. And then after that, you can recreate a new clean file after you've done with your manipulation, and you can even regenerate it as linearized and so on with such a tool. So basically, from any PDF to a form of PDF that you can easily modify, you do your modifications and your fixes or whatever, and then you can revert back to a clean PDF with another calls of a tool like MuTool or QPDF. So yeah, that's it for today, I think. Do you have any questions? I see no questions. So yeah, we covered the different kinds of PDF in the wild, how to identify what they're a bit about, how to turn them back to a form to easily modify, and then also remove the encryption, which is not easy, not difficult at all, but just it's good to understand what it's really about. It's not genuine encryption when the password is empty, but why you may be prevented to print or modify a copy from the file. So next time you have a PDF that prevents you from copy pasting, just decrypt the PDF and open the copy, and very most likely it will work out of the box with the exact same rendering. So very useful trick when PDF decide for whatever reason. I think that I have some stream PDF. Yeah, exactly. This PDF specification what can't I do? I cannot copy, right? Document manager. This is a PDF specification from region 1, and so qpdf --decrypt tag decrypted specs.pdf. It takes, how long does it take? It takes too long, or did I do something wrong? It's slow. I'm not sure why. Did I do something wrong? Or is the file so big? Okay. I'm not. It's still taking its time. This is weird. I expect it to be pretty instant. Or is it because the file cannot be opened? Okay. Is it failing or something? Let's try again. Okay, this is very slow. I'm not sure why it's breaking. Maybe because there's owner password. I'll have to check. Okay, this doesn't work always. Interesting. I wonder why. I will check. I will check for the next streams. Okay, so, or maybe it will just finish. I will keep it running, and I would add a comment to the video, to the stream after it's done. Okay, so no questions. So thanks a lot for your attention. Now you are ready to be able to modify any PDFs in the wild, or at least most of them, and understand what they look like. And yeah, I thank you for your attention. And yep, see you next stream, everyone. Bye bye. Thanks for watching.